Hi, I'm Paul Emms, and I'm here to teach you the process of translation. Now, yes, it's not the most exciting material, but I'm going to try and explain it in a way that makes at least a little bit of sense for you. So basically, what we want to do is take a strand of mRNA, which I have here, and read it, and eventually get a protein, otherwise known as a polypeptide. Either or works. So if we take a look here at this mRNA, one rectangle is actually a nucleotide, and if we group three of those nucleotides, we get a codon, and the codon holds the code for one of the amino acids. Now, therefore, this is a whole chain of a bunch of translation process actually take going through the ribosome, and this here is a very artistic drawing of said ribosome, and so basically, just to clarify again, the protein translation is a process by which we're going to take a piece of mRNA and we are going to run it through the ribosome, and the ribosome is going to put together the corresponding amino acids, and otherwise known as polypeptide. Now, ribosomes are found in both the cytoplasm and the rough ER or endoplasmic reticulum. The ribosome is actually made up of two parts, one larger than the other. The mRNA then runs in between those two parts, and that's exactly where it gets read. So, now you must be wondering, where do these amino acids actually come from? Well, floating around the cytoplasm and the endoplasmic reticulum are these molecules called transfer RNA. Now, if we take a look here, we have our ribosome and our mRNA being read through it, and the new part is our tRNA. Now, the tRNA, as you can see, carry around a amino acid. Here we have the amino acid proline. Now, these tRNA molecules are floating around looking for your mRNA where they can attach and eventually be read by the ribosome and eventually be turned into a polypeptide or protein. So now we will take a further look at the mRNA. So here's our piece of more informed mRNA. Now, if we take a look here, in orange we have the non-coded region. Now, this actually does not get translated by the ribosome at all, but it does have some duties, but we'll get to that later. Now, next along the chain, we have the Shine-Delgarno region, or sequence, I guess, which is what actually the ribosome will recognize and it will know to bind to. So, as we continue on, we have a little bit more of the non-coding region, and then we hit the start codon, which is actually AUG. Now, once the ribosome hits the start codon, it knows to basically start translating, and from here all the way here it will read all of these codons. Now, usually in a regular human polypeptide, we'll have anywhere from 200 to 300 amino acids. Obviously there's not nearly as many here as a group of 3 is 1. So the ribosome will read all the way over until it hits the stop codon. Now, very basically, when it hits the stop codon, it is told to stop reading, and yeah, the ribosome is done. So now I will explain the actual process of translation and how it really works. The first step is known as initiation, and I have a little diagram here, which is basically what we've seen before. It's a little more in detail, but I will explain. So basically, we have our ribosome reading our mRNA, and the mRNA here has the Shine-Delgarno region, where the ribosome recognizes and attaches and begins its process. Now, as it gets over to the start codon, that is where it begins reading, of course, and again, the start codon is coded as AUG, just so we know that. Now, inside the ribosome, we have 3 sites. We have the E site, we have the P site, and we have the A site. Now, back at the start codon, which again, AUG, which is in the P site, we take the corresponding tRNA molecule, which is this little T here, which we saw last time, and it is going to line up with the AUG. Now, the anticodon on the tRNA molecule is UAC, which of course is the corresponding, or is complementary to AUG. And it is holding on to the amino acid known as formal methionine. And this will be our first amino acid in the polypeptide chain. Now, that's basically more or less the first step in the process, and the second step is known as... So continuing on with elongation, basically we want to take a look at this here again. I know it's small and hard to see, and I apologize. Hopefully we can make do. But if we can pretend that the codon after our start AUG one is coded as AAA, the corresponding tRNA molecule would in fact be UUU, and is going to line up with the AAA codon. So we can see that here. So we have the tRNA with the UUU, and it is lining up right there. Now, basically, just to understand a little bit better, these tRNA molecules are floating throughout the ribosome, like I said previously, and basically, more or less through trial and error, they line up with the codon, and if their corresponding code fits, it's a match, and they go along with the process. If not, try again later. So, to get back to the whole elongation step, we need to take a look at the bond here between the tRNA molecule and our first amino acid, the formyl methionine. Now, what happens actually is that bond will break, and when it breaks, it will release a lot of energy. Enough energy that is needed to build a bond between our first amino acid and our second one with our AAA tRNA molecule. There is now a bond between those two, and our first amino acid will break off and come up, and that will be the beginning of our amino acid chain, which will eventually turn into... So basically that step will continue to repeat itself, and the mRNA will continue to go through, it'll continue to get read, more amino acids will break off, building our longer polypeptide, and eventually into our protein. So now once we get all the way down our mRNA strand, we get to the stop codon, which is actually our last step. Now, that step is called translation, and pretty simply, the ribosome will get all the way through the mRNA to the stop codon. It will then, once it gets there, it will realize that it's done, it will stop reading, it will break off, the protein will be there, and yeah, that's basically the process of translation, more or less. I hope it wasn't too confusing, and I know the images were a little bit small, but I hope you got the gist of it, and yeah, maybe you learned something, maybe not. But anyway, thanks again. I'm Paul, and thanks for watching.